car is driving back and forth along a straight road. The distance that the car is from a given gas station at time t is given by S of t equals 5 times t plus 1 times t minus 3 squared, for t is greater than or equal to 0. The distance, S of t, is given in miles and time t is given in hours. Was this one calculator active? Let me look at the solutions. It doesn't say so. Okay, yeah, all right. No, I don't think it's calculator active. Okay, all right, so S of 2, we're just plugging in 2. This is not really a calculus problem. We're doing 5 times 2 plus 1 times 2 minus 3 squared. And technically, you don't have to even simplify that, but for you to write a sentence about this, it's going to be a whole lot easier if it's just a number. So I would simplify this. It's going to be 5 times 3 times negative 1 squared, and that is just going to be 15. So S gives you the distance from the gas station, right? So we're plugging in 2, so that's our time. So at 2 hours, the car is 15, what's this measured in? Miles from the gas station.
So can you can put those equal signs on FRQs and not that means that the S of 2 would be there?
Yes, you can. As long as you label it up here and it's like a logical sequence of equal signs, you don't have to write it every time. Yeah. Yeah, even on the AP exam. For limits, it's the fact that limit is part of what you're doing. Like you couldn't just not write the 5. Right, and then suddenly at the end get the right answer. So not writing the limit notation is kind of like not writing that 5. It's part of what you're doing. But the label up here, this is really just a label. You just have to write it one time. Okay? All right, so we're supposed to now find S prime of 2. And that means we got to find the derivative first before we can plug in 2. And although we did just use product rule, we do not know how to solve this product rule where it's got that square right there. We're going to learn it eventually. But the best thing to do here is just going to be to expand it. So you're going to distribute that 5. So right now we're not taking the derivative. It's still S of t. So you'll have, but the 5 only goes to the t plus 1. It can't go to both things. So you'll have 5t plus 1. Or, I'm not 1, 5. Right there. Fix that. And then we'll have, I'm going to go ahead and expand this, t squared minus 6t plus 9. If you want, you can wait till the end to distribute the 5 if you'd rather not, and you can, but you're definitely going to have to do that t squared minus 6t plus 9 early on. And then if we distribute here, we will get 5t cubed minus 30 t squared. I'm just distributing here, plus 45t, and then I got to distribute the 5 plus 5t squared minus 30t plus 45. And then your life will be easier if you combine your like terms. So you're going to get 5t cubed minus 25t squared plus 15t plus 45. And so once you get it like this, it's just a power rule derivative. So S prime of t is, S prime of t would be 15t squared minus 50t plus 15. And then if we want S prime of 2. We just plug 2 in to this. And technically you can leave it here, but again, you got to write a sentence about it. It's going to be a little easier to do with a number. So that would be, go back up here. That would be, let's see, 4 times 15 is going to be 60 minus 100 plus 15, which is going to be negative 25 there. Alright, so if you think about what's happening here, you've got, this is your T, this is your S of T, this is in hours, this is in miles, right? We got some sort of graph right here. We are finding the derivative at 2. So since it's at 2, we need to say at 2 hours. All right, so let's say 2 is right here. We are finding the slope of the tangent line, right? So slope of the tangent line, that was kind of hard to draw actually, right here, is going to be change in y over change in x. So thinking about your limits will help. Change in y over change in x, not limits, units. This y is miles. This x is hours. So the answer you're getting, this is negative 25 miles per hour, right? So what is that going to be? It's your velocity. The velocity. If it gives you distance or position is your original problem, velocity is the derivative, yes.
Is there any other things that the derivative would be, or are they mostly going to give you problems where it's velocity?
If it has something to do with distance or position, the derivative is velocity. What you might see is ones where the they give you velocity and you take the derivative and it's acceleration. But we'll get to some of that later. So at
What time are we late?
in 10 minutes, that lunch is in the middle.
Oh.
And like if you're going to second lunch, you go back to fourth period for 10 minutes. So it is. They were just throwing something together to get us through the rest of the day. It's, yeah, and they had to let middle school eat lunch, so.
Yeah, I think
That it messes, yeah,
I
yeah,
think middle school's lunch is 12:25.
yeah, yeah. So it's a mess. So the velocity of the car is negative 25 miles per hour. The negative means it's going away from the gas station. Okay. C says, is there ever a time from 0 to 4 where the car reaches the gas station? So, if the car reaches the gas station, what function would equal a certain value? S of t would be 0, right? Because if the car is at the gas station, its distance from the gas station is 0. So, we want to see, we really don't care about the derivative here. We care about S, and we want to know if it ever has to be 0. So this sounds to me like an intermediate value theorem problem, right? Because they've given us an interval to look at. So first of all, this is a polynomial, so it is continuous. So we would want to say S of t is a polynomial. So it, oh, don't do it. Don't write that. What should I write instead of it? S of t. Why did it just erase? Okay, there it goes. So S of t is continuous. Okay. Then I want to find S of 0, which is going to be 5 times, what is it? 0 plus 1 times 0 plus, no, minus 3, which is going to be 5 times 1 times negative 3, that will be negative 15. S of 4 is going to be, I'm really running out of time. Oh, it is squared, which makes it positive, which gives me a different number. What do you get there? 45. And then you're going to plug in 4. What do we get on 4? I'm going to skip over to the solutions and just write it down because I'm running out of time. I did something else weird there. Don't do it that way. I don't think. What do we get? 25? 25. All right. Since S of 0, which equals negative 4. Oh, wait. Oh, shoot. Oh, I did.
Yeah, that's what I thought.
It's not intermediate value theorem. I should have looked at my game. Set it equal to 0. It's already factored for you. Gosh, sorry, guys. I should have looked at it. Intermediate value theorem could be used there if you got numbers that were above and below 0, but they were not. That doesn't necessarily mean it doesn't go to 0. It just means you can't prove it that way. Yeah, you set it equal to 0. T minus 1, t, t plus 1, t minus 3 squared. Set it equal to 0. T plus 1 equals 0. That gives you a negative 1. That does not, it tells you t is greater than 0, so that doesn't work. This one's going to give you t equals 3. So the car is at the gas station.
Where did you get the T equals 3? Oh.
You were just setting that t minus 3 equal to 0. Yeah. It's already factored for you, so when you have something factored, you just like set the parts equal to 0.
Well, if you divide by
Yeah,
0,
because the 5 does not have a variable, so if you do set it equal to 0, it's not true, so you don't get anything from that. If you had a t with a 5, you would also have a t equals 0 as well. Oh shoot, I'm just going to have to go. Now is that intermediate value theorem? It is, isn't it? Or no, set the, okay. All right, so if the car stops, what is its velocity? 0. So you want to take your velocity function, which is 15t squared minus 50t plus 15, and set it equal to 0, right? And to solve that, I would do a greatest common factor first, just to get the numbers to be a little smaller. So you can take a 5 out, you'll get 3t squared minus 10t plus 5 equals 0.
would it be so plus 3?
Yes, it would be. It's falling apart, guys.
Striking out like
All right, then, is that, yeah, it'll factor. 3t and t, and if I do a negative 3 here and a negative 1 here, that will give me, if I multiply it back, 3t times t give me 3t squared. I'll get negative 9t, negative 1t, and then they'll get positive 3. So this will work. Then you would set each one of those equal to 0. So you got, the 5 doesn't really matter because it doesn't have a variable with it. So that's going to be 3t equals 1, which means t equals 1/3. And then over here you got t minus 3 equals 0. So t equals 3. The car stops at t equals 1/3 and t equals 3. Does that help on that one?